Okay, guys, it's me again. I wanted to go over 6.2 with you. This is a pretty lengthy chapter, so with a lot of practice and everything, so I wanted to take the time to go through these one by one as I get them done. So you can kind of split up your time, hopefully, and go from there. I'll also do chapter 7 as well, since we've already gone over that. You'll be having a quiz on that on Tuesday. So remember that on chapter 2 we talked about adding or subtracting a constant, how it affects the mean, standard deviation, shape, and multiplying, dividing as well. So we're going to kind of take that to another level. Okay. So these skip tours offer a half-day trip in a tour period. There must be at least 2 passengers for the trip time, and the vehicle will hold up to 6 passengers. Define the number of passengers on a randomly selected day. So we've calculated the mean and the standard deviation. I wanted to kind of show you that also on the calculator because I couldn't do that last time. I have one that shows up now. So what you can do is press your stat button, okay, and then under edit, you want to put in all your passengers 2, 3, 4, 5, and 6. And then next to them, you're doing your probabilities. So that's 0.15, 0.25, 0.35, 0.2, and 0.05. Okay? Then you're going to do stat, calc, and run one var stats. You have your list as L1, but in your frequency, you need to put L2. So in order to do that, you're going to press your second key, which is the blue key, and then press the number 2, which is L2. Okay? That brings in this probability in here. Okay? So then you calculate in your, oh, our mean is different. Maybe I got it wrong. So they said I think our mean is 4.038. So I must have calculated it wrong the first time, guys. I apologize. So it's 4.038 is our mean, and our standard deviation is 1.09, which is right here. Okay, so that's kind of helpful, so you don't have to do it so drawn out. I wanted to do it a couple times manually because I do think it's a process that you guys need to understand and how it's done. So when we do transformations here, he's now charging $150 per passenger, and we still have the same probability and stuff. But let's go ahead and take a look, and I'm going to go ahead and go back into my list. And I have the same probabilities, 0.25, 0.35, oh, that's why I did it wrong. Oh, rats. So this is 0.2 and 0.05. So I'm going to do I'm going to do this again. Calc 1 var stats. And yeah, it's 3.75, and our standard deviation is 1.09. Sorry about that. Okay, so using that, now we're going to change our x value. So we're going to go back, stats, and now we're charging $150 per passenger. So we're going to multiply by $150 for each one of these. So this now becomes 300 and 450, 600, 750, and 900. And I'm going to run the mean and standard deviation again. So stat, calc, 1 var stats, and this already has the L1 and L2 there, so that's helpful. And I calculate it, and my mean is 562.50, and my standard deviation is 163.5. Okay, so that should hopefully help you guys a lot with that calculation. So what happened there? What we did is we took that, our mean was originally 3.75. So if I took 3.75 and I multiplied that by 150, I should get 562.50. And the standard deviation, if I took 1.09 and I multiply that by 150, my new standard deviation is 163.5. So whenever I multiply by a variable, I go ahead and I multiply both the mean and standard deviation by that amount. So let's go down to our rules. These are the same rules that we've discussed since chapter 2. So this should just be going back over and over again. It's just we're just kind of driving home the same thing. So remember, when you're multiplying or dividing by a constant, you multiply the measures of center and the location by that constant. You multiply the measure of spread. So MOC is measure of center, and MOS is measure of spread. Okay? It doesn't change the shape of distribution. So remember, measure of center could be mean, median, mode. It could be any of the quartiles because these are locations and percentiles. Measures of spread is standard deviation and quartile range, and all that stuff, okay? Now, look right here. Multiplying a random variable by a constant multiplies the variance by b squared, since the variance is the standard deviation squared. So be very, very, very careful with that. So once again, El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. So we're going to be talking a lot about El Dorado Community College. So we'll be going back to this example over and over again. The number of units that a randomly selected full-time student is taking in the fall semester has the following distribution. So I'm going to go ahead and do the mean and standard deviation again. So let's go ahead and you can reset your calculator, and under stat, you're going to enter in the number of credits. So we've got 12, 13, 14, 15, 16, 17, and 18, okay? And then the probability is 0.25, 0.1, 0.05, 0.3, 0.1, 0.05, and the last one is 0.15. Okay, so then I do stats calc and I run the one var stats, remembering that list is from L1, but to get to my frequency, I press my second and 2 button, and that gives me L2, and then I calculate. So my mean is 14.65. My standard deviation, I got 1.69. My variance, 1.698. So let's see. Let me double check my numbers again, because watch 12, 13, 14, 15, 16, 17, 18. So 0.25, 0.1, 0.05, 0.3, 0.1, 0.05, and that's why. 0.15. See, this is always what happens. So then I'm going to do stat calc. There we go again. There we go. Okay, so I got approximately 206. A mean was 14.65, and my standard deviation is right here. I can just go ahead and square my standard deviation and get 4.23. Now, when we're doing some more things, we're charging tuition, so $50 per unit. So we're going to multiply each one of those by 50. So we have to transfer all this. So this is 12 times 50, 13 times 50. And we transfer these variables in here. And then we calculate the mean and standard deviation again. Now, let's look at this. The mean of 14.65, if I'm going to multiply that by 50, I get 732.5. And then standard deviation is 2.06. I multiply that by 50, and that's 1.03. Variance will be 4.23 times oh wait, I'm sorry, 4.23 squared. I'm sorry, I'm not doing that right. So anyways, so it's 10,575. I think what I have to do is square this. So it's 103 squared times 50. No? Oh, Lord have mercy. So remember, let's multiplies the variance by b squared. So let's do, oh, Lord have mercy. So take your variance. So our b is 50. So we square that. And then we multiply that by 4.23, and that gives us 10,575. Good Lord. So remember this, multiplying a random variable by the constant. So remember, you have to square that constant and then multiply it by the variance. Okay? I know I was doing something wrong. Okay. So again, consider Pete's chores again. We define C as the amount of money Pete collects. So go ahead and do me a favor and calculate your mean and standard deviation. Go ahead and pause the video if you want to. I'd like to see you use that. Use your calculator and check your work. Okay, so I did that and I got a mean of 562.50 and a standard deviation of 163.50, and that was the same thing that we got last time. Now we're doing a transformation where he has to spend $100 each time. So now we're trying to calculate the profit. So we're going to subtract $100 from each one of these. And let's go ahead and calculate the mean and standard deviation. So if you notice here, when I did this, I got the mean minus 100, but the standard deviation stayed the same. I'd really like you guys to try to calculate these out again just to double check. All right, so now that just leads up to our rule of adding and subtracting. So you add to the measure of center and location, but it doesn't change the shape or the measures of spread. So go to 6.2a here and figure out what the probability and standard deviation of charging $50 per unit. We already got these down, I think, didn't we? No, but go ahead and do the mean and standard deviation for 6.2a, okay? And then try to do the second part where you have to add $100, okay? So you do this and then add $100. So once you go ahead and pause the video and try to complete this whole example. Okay, well, if you're able to do that, so your mean and standard deviation got to be 732.50 and the standard deviation was 103. I did this manually, but again, I strongly urge you to do it in the calculator after you understand how it's done, okay? Then what happens is we added $100 to each one of the costs. So we could do the mean and standard deviation again. Now, I'd like you to run this through your calculator since it doesn't take a long time to do, and then see for yourself that your mean is going to be $100 more, but your standard deviation is not going to change. All right, so it's very important that you guys understand how this stuff affects your measures of center and spread, okay? All right, so moving on, we're going to go ahead and just summarize everything that we've done for 6.2. The effect of a linear transformation on the mean and standard deviation. Remember, if you're a linear transformation means you're adding and multiplying at the same time. The mean, you're adding and multiplying by that number b, and then the standard deviation is you're just multiplying that standard deviation by the absolute value of b. So that's the absolute value times the standard deviation of x. Okay, and then the variance would be b squared times the variance of y. Okay, so this is also on page 363, this example right here, where we're doing transformations with changing from Celsius to Fahrenheit. Okay, so the first thing, we took a mean and standard deviation right here, and then we found the new mean and standard deviation when we are transferring from Celsius to Fahrenheit. And we plug those into our equation right here. All right. Now, to do the linear transformation, and now we're doing a, from there, we're going to say the temperature of a baby's bathwater should be between 90 and 100 degrees. Find the probability that the water temperature on a randomly selected day it meets the recommendations, and show your work. So the first thing is we have to find an interval. The interval is between 90 and 100. Now, what I did is I calculated z-scores, and then I looked up the area on table A and took the difference of the two. But if you're not doing a if you're not doing that, if this is like a multiple choice question, what I would suggest you do is you have your new mean and standard deviation, right? Okay, so then I'm going to go into second VARs and go into normal CDF. Okay, since I'm using table A, this is CDF, I'm getting an interval. Sorry. So second VARs, and I'm going to go into normal CDF. Okay, and then my lower bound is going to be between 90 and my upper bound is 100. My new mean is right here, 93.2. And my standard deviation is the new standard deviation with the linear transformation applied. Okay, I plug that into my calculator and I get 78.3935, and here we got 78.39. So there's about a 78% chance that the water temp will meet the recommended temperature. Okay, so we can now take this transformation. The idea is that we take this transformation and we apply it and find a probability based on that and set up we're setting up kind of a confidence interval, sort of, not really, an interval. Okay, so again, we're doing the same thing for this one right here. I would like you guys to go ahead and start off with the first part right here, and then take that part and try to calculate the probability. So the first thing we do in a large introductory statistics class, it was normally distributed with a mean of 17.2 and a standard deviation of 3.8. So our mean started out at 17.2 and our standard deviation was 3.8. The professor decides to scale the scores by multiplying the raw scores by 4 and then adding 10. So this is the linear transformation. They multiplied by 4 and added 10. So we need to find a new mean and standard deviation. So the mean we just plug in into the whole equation because we add and we multiply. So we get 78.8. For the standard deviation, we just multiply by the 4. We don't do any addition or subtraction because remember that does not change the standard deviation. So we get 15.2. So then we take it a step further and decide what is the probability that a student has a scale test score of at least 90. So remember, if they want it to be at least 90, they want it 90 or above. Okay? So here you can do the z-score, which I calculated right here, and find the area underneath. The area underneath the curve is right here, but since I'm doing above, I have to do 1 minus that area. Okay, so this is a lot of repetition for you guys, same kinds of stuff that we've been doing, but let me show you how I would do this on my calculator. Okay, using my new mean of 78.8 and my standard deviation of 15.2. Remember, they always expect to see something like this, so make sure that you show everyone that you understand that. So then I'm going to do second VARs, normal CDF. Okay, the lower bound is going to be 90. The upper bound is some number we don't know, but we do put a very large number in there just to make sure we get everything. Our mean is 78.8 and our standard deviation is 15.2. When I plug it into my calculator, I get approximately 23%, which is very close to what we have here. Okay, so that's where we are with that. Okay, so you need to be able to form these linear transformations, and then you need to do probability with those new linear transformations. So hopefully that is helpful. Okay, now when we combine two random variables, this kind of example, I don't want to spend too much time on it. I feel like it's a little bit of a waste of time, and this is a long section, so I want to make sure your time is valued. So let's go to some of the definitions that we have here. Okay, the only way to determine the probability of any value of t is if x and y are independent. If knowing whether an event, so what does it mean to be independent? So again and again, it's so important that you guys understand the idea of independence and mutual exclusivity. Remember, independence means that it doesn't affect any other event from occurring, the probability. Okay, so oftentimes we're going to assume independence, and if the outcomes are unrelatable, like if the two instances are unrelatable, okay? You need to make sure that you're assuming independence, your assumption of independence is reasonable. So if we're going to have an example where it's not reasonable to assume that these two events are independent, and I'm going to give you a good example of that as we come up. So let's go ahead and move on to that. So when we're adding the sum of random variables, you're adding the means, okay? But you don't necessarily add the variances. Remember that you have to, we have to take their variances and do not add the standard deviation. So you add the variances, but do not add the standard deviation. So to get the standard deviation, I would figure out what the new variance is and then take the square root. Okay? So to get, when you're adding two variables, you take the two standard deviations, turn them into variances, which means you basically square them, then add them together and then take the square root. Otherwise, you will get it wrong. So it's very important that you do this. So take a minute to read this example, 6.2. We're talking again about El Dorado Community College and the number of units that somebody takes per semester. Go ahead and then we have a on campus, the main campus, and then the city campus. Different distribution, and we have different means here. Okay, so now we're going to try to figure out what is the new mean and standard deviation of both of these. So if I'm doing the means, again, I just add them together. So I have one mean of 14.65 and another mean of 15, and I add them together. Okay, for the standard deviation, I took the variance. This is the variance. And I took this variance and I added them together. Because remember, that's the standard deviation squared. I added them together and then I took the square root. So I got approximately 3.10. So if I wasn't given the variance, I would have to square this number. And if I look right here, 2.06 squared is 4.23 or 4.24. So be careful with that. You're going to have to, if you're not given the variance, you need to go to this, square it, and then go to this guy, square it, and then add them together, and then take the square root. Okay, it's very important. It's a common mistake, so be very careful with that. Okay, almost done with this section. So if we have, now we're doing, we do another sum of means here. So the amount of money spent on books for this fall semester is, here's the mean for this one, and this is the amount of money spent on books and the overall cost of tuition. All right, so the mean of those, I can add them together. But then they're asking you about the standard deviation. Now, is it really, if you're spending a larger amount on tuition, that means you're probably registering for more classes, which means your books are probably going to be, book expenses are going to be more as well. So you cannot assume that the money that you spend on books is independent for tuition and fees, okay? So I stop right there and I say, I'm not going to, I can't calculate the standard deviation because I can't assume that the cost of tuition and the cost for books is going to be independent of one another. Okay? So be very careful of that. This is a great example of why you can assume independence in most cases, but in some of these cases you need to think about it. And is it really reasonable to assume independence? And in this case, it's not. Okay. Almost done, kiddos. All right, so when we're taking the difference of random variables, you would subtract the means, but when you're doing the standard deviation, you add them, which sounds very strange, but it's true, okay? So look down at the bottom of the page where you have a sample problem, where you're taking the difference of two means and the difference of the two standard deviations. Take a minute and pause the video and give this a shot, okay? And then come back and check to see how you did. Okay, so the other thing I did here was I interpreted each of these values, which is so important. If they're asking you to interpret them, you need to put them down in words. So when I subtracted them, remember that order is very important. So I used t first, and so I get a negative mean, and I have a positive standard deviation because I'm adding them together. So take a look at the interpretations of them. So on average, students on the main campus take 0.35 less credits than the downtown one. So that's a good interpretation of the mean. And then the standard deviation is 3.10, which means the difference in the average number of credits will vary about 3.10 from the mean of negative 0.35. So remember, you mentioned the standard deviation and you actually mentioned the mean as well, okay? All right. So now we're combining normal distributions, okay? And this is our last section of this section, and then we go on to binomial, okay? If it's normally distributed, we can use its mean and standard deviation to compute probabilities. All right, so normal random variables is that the sum or difference of two independent normal random variables is also normal, okay? So if you look at page 374, this is the same example that we used, okay? So Mr. Starnes likes between an 8.5 and 9 grams of sugar in his hot tea. They actually worked through this entire example for you, and it's phenomenal. So one of the reasons why I really want you to pay attention to your book. So suppose the amount of sugar in a randomly selected packet follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. If Mr. Starnes selects 4 packets at random, what's the probability that his tea will taste right? So we have a new mean and a new standard deviation because we're doing it 4 times. So you're adding these means together 4 times, and then you're doing the standard deviation as well, being very careful to do that. Now, you can use normal CDF if you want to, or you can use your calculate your z-scores and take the difference between the two values. Okay, so what I did is I calculated my z-scores, and then I found the area for each one of these z-scores, and I took the difference. Okay, I did not. You can probably you can remember it has to be between 8.5 and 9 grams. So you can take the difference between these two. So just be really careful of that as well. Or you could just go ahead and plug it into the calculator as well, where this would be 8.5 would be your lower bound, 9 would be your upper bound, and you use your new mean and standard deviation. That's the key. So I did the same thing down here with your mean and standard deviation. Speed daters, so what is the probability that a randomly selected speed dater is taller than the randomly selected female? So we want their difference to be greater than 1. So you're using your normal CDF and you're finding what's the likelihood that the difference will be between 5 and 0. So that's, or 5 or greater. So that's 5 would be your lower bound, and 4.61 is your, wait a second. Yeah, the difference in our means is 5. So our standard deviation is 4.61. So what's the standard deviation that it'll be 5 or greater? So it's greater than 5. So it's, you could do 1 minus the area that you come up with on the C table. But again, normal CDF is the way to do it. So sorry, I kind of fumbled that one for you, but hang in there, okay, and see if you understand it. Okay, the last section is on binomial distribution. I'm going to do that one later, but hopefully this gets you far enough to get you going. Remember, you have to do notes on all 3 of these. I hope this is helpful. Talk to you later. Bye.